Hey, it's Estrada here, and in this video I'm going to show you how we can apply multiple locus theorems to solve compound loci problems. So let's get to it with some review first. We've looked at 5 locus theorems so far, so that's why we've had 5 separate videos prior to this one. In the first video we looked at the locus of points a fixed distance from a point. That was the cell phone video, and remember the next day we did a cell phone tower investigation sort of thing, and we said that the locus of points a fixed distance from a point will produce a circle. Then in the second video we looked at another locus condition, fixed distance from a line, and we said that the locus of points a fixed distance from a line will produce a pair of parallel lines a fixed distance away on either side of that line. Then the third video we did a locus of points equidistant from 2 points, and we said that will produce the perpendicular bisector of the 2 points. Fourth video we looked at the locus of points equidistant from 2 parallel lines, and we said that that will produce a single line midway between the 2 given lines. And then the last video we just had prior to this one, locus theorem 5, equidistant from 2 intersecting lines, and we said that in that locus theorem you would have the pair of bisectors that bisect the angles formed by the given lines. So in today's video what we will be doing is in a problem you're going to have more than one locus condition. That's why it says compound loci. Compound means more than one. So let's get to that, and I'm going to give you some guidelines first. I want you to copy these down into your notebook. Let me try to fit this into a single screen, and here are the guidelines I'll be using. So make sure you get those, and I'll go over each one of these bullet points as I work out example 1. So let's look at example 1. Example 1 says, on the set of axes below, graph the locus of points that are 4 units from the line x equals 3 and the locus of points that are 5 units from the point 0, 2. Label with an X all points that satisfy both conditions. See if I can enlarge this a little bit. There it is. Okay, so our first bullet point says plot any given points and lines, and make sure that you plot the given lines as solid lines. So the given line is x equals 3. So let's go ahead and plot that line. The line x equals 3 is right over here. Oops. Alright, there it is. So got the line x equals 3, and given lines, they should be solid lines. So that's why it's a solid line for me. That's supposed to be an arrow. Let me do that again. So there's a line x equals 3. Okay, then we're also given a point, the point 0, 2. So let's go ahead and plot that. 0, 2 is right over here, and you always want to label your points. So that's the point 0, 2. Okay, the next bullet point says underline the locus conditions given in the problem and understand that you will be plotting more than one locus condition. Alright, so the first locus condition is 4 units from the line x equals 3. So I'm going to underline that. And the second locus condition is 5 units from the point 0, 2. So you need to understand that these are separate locus conditions. Okay, so you're going to be plotting more than one locus condition here, and the first one is 4 units from the line x equals 3. So let's only focus on that right now. Here is the line x equals 3, and I want to plot the locus of points 4 units from the line x equals 3. Well, I could begin by plotting 1 point, 1, 2, 3, 4, right? This point is 4 units from the line x equals 3. Then I can just move along the line x equals 3 and just keep plotting more points. Eventually, you're supposed to realize that these points I'm plotting will form a line. So I could have just sketched a line just like that, 4 units away from x equals 3. Now, understand this also, right? I can also go on the other side of x equals 3, put a line there as well, and every point on that line will also be 4 units away from the line x equals 3. So that's the first locus condition. We just did this bullet point, sketch the first locus condition. There's another locus condition, remember? And it was 5 units from the point 0, 2. So 5 units from the point 0, 2, that's a fixed distance from a point. Right? If you go back to when we did our review of the locus theorems, that's fixed distance from a point, right? 5 units from a point. So you know that's supposed to produce a circle. So I'm going to grab a compass. Where's my compass? And I'm going to measure. That's not what I wanted to do. Do that. I'm going to measure 5 units from this point. My computer seems to be acting up a bit. So that's 1, 2, 3, 4, 5. So you want to open your compass up 5 units. And what you want to do is just sketch a circle. And do your best to make sure it's a dotted circle. Then it says label with an X all points that satisfy both conditions. So basically, wherever the dotted lines intersect with the dotted circle, that's what you need to label with an X. That's why I'm very insistent that the locus should be dotted, because this part is easy. All you have to do is just see where the dotted lines intersect with a dotted circle, and it's easy peasy. So these are the 2 points that satisfy both conditions. I don't need to state the points, I just need to label them with an X. But if I was asked to state the coordinates, I would make sure that I state the coordinates. And that's it, right? Those are the only 2 points that satisfy both conditions. Because it is only at these points that you will be 4 units from the line x equals 3, and you will be 5 units from the point 0, 2. Okay, example 2. In the diagram below, car A is parked 7 miles from car B. Sketch the points that are 4 miles from car A, and sketch the points that are 4 miles from car B. Label with an X all points that satisfy both conditions. So they already plotted the 2 given points for us. There are no lines, there are no given lines here, so I could skip that step. And I can go right into underlining the locus conditions. So one of them is 4 miles from car A, and the other locus condition is 4 miles from car B. All right, now, these cars are parked 7 miles apart, right? So it says car A is parked 7 miles from car B. So they are 7 miles apart. Sketch the points that are 4 miles from car A. Understand this is a fixed distance from a point condition, so that's going to produce a circle. So I'm going to get my compass out. Now, here's the thing. You have to be conscious of the fact that these cars are 7 miles apart. So if I want to know how far 4 miles is, I know that I should go past the halfway mark, because the halfway mark is 3.5. Just above the halfway mark should give you 4. You don't want to go all the way to car B, because then that's going to be 7 miles. And you're going to sketch your circle here. So there is the locus of points 4 miles from car A. Now you're going to do the same for car B. And I'll keep the compass setting the same simply because car B, it says sketch the points 4 miles from car B. So that's also going to be a circle. And there's my circle. Okay, that took a while. So now label with an X the points that satisfy both conditions. So that would be here. And of course there would be another point of intersection here. So you get 2 points of intersection. Okay, so I hope this video helps with solving compound loci problems. Take care.